Hey guys, so in the last video I explained to you all the aspects of this function and I showed you what you need to input. So now I'm going to show you how to actually run the function. So I created a file called data analysis, which is just going to be the script to run the function that we just explained. So first thing, a variable called start time. So this, as I explained before, this is the time that we started our eChem experiment. So if I go back to my data, eChem, I said here, this is 7:51. This is the time that we're going to use. But because of the time change, we have to take out an hour away from this number. So the start time here will be 6:51:57. The limits, as I just said, for the first time you do this, you won't really know these numbers. But as you go on, you'll be able to change these numbers so that all the plots are on the same limits. If we go to our data, here we have 16 scans or 16 measurements. So the number of scans here we changed to 16. So this is the number of scans. All right. Sample name. So this is, as I said, the code will automatically add underscore and the number. So here we put, so you see this is the file name, sample2 2c underscore 5 underscore angle. MATLAB automatically puts this last part. So all we need is just the beginning here. So sample2 2c5. And then we can just write this in. This is the how the function starts to work. We can press run, and now MATLAB will open new folders for each run that we do. It'll do this 16 times because we have 16 data files. So I'm just going to let this run. So now it's done it 16 times. The last part it has to do is do the comparison of over time. And you'll see now for the 16 points, and there's the chirp sound. So now we know that it's done. So here we're doing intensity over time. So now it just opened a crazy amount of windows. So I'm just going to close them all. I'm going to just do close all. Okay. So let's see what the data looks like. If we go into the folder where we saved this file, you'll see now we have a bunch of new JPEGs. So if we open it here, so now you see what I was talking about. For the initial function, we show normalized intensity and the beam angle. So we have K alpha, iron K beta, the ratio of arsenic to iron for K alpha. Then we have arsenic K alpha, arsenic K beta, and the ratio. The information that we wanted, the time since we started our eChem. So this will allow us to know, are we charging, are we discharging, or are we resting? The energy that we used, the sample name, and which number. So here see it says scan 1. If I click to the next one, you go to scan 2. You'll notice here that these limits have stayed the same, even though the values have changed. You'll notice here it's changing. That's what I mean by limits. So this is, I set them so that the line is in the field of view and zoomed in as much as possible. So if I scroll through here, you'll notice I'm going 3, 4, 5, and we're just increasing until we hit all 16. So now we've done all 16. So if I close this, the last new image file that we have is called time comparison. So here we're seeing, before we're seeing intensity versus angle. If I open time comparison, we now have intensity over time. And we see the blue line is for 0 degrees and the red line is for 60. So now we're able to look at both the changes over the angle and the changes over the time. So using the XRF angle scan function, we can analyze all of our data to see how the intensity is changing with angle and over time.